Now that the food has been swallowed, let's take a look at the stomach and see what happens to it. So remember, we had a bolus is the chewed food that is swallowed. And it goes down the esophagus, so the bolus would be coming through here, through the esophagus into the stomach. So the stomach is this muscular container. It is made of smooth muscle, and it is basically a storage container for the food. There's several functions of the stomach. The main function of the stomach is this storage. Here's a short video to kind of show you how the stomach works.
Proceed.
Okay.
Ta-da!
So in that video, he wanted to carry all of the groceries at once. He didn't want to make separate trips. So the man was like the stomach. With your stomach, you can eat a bunch of food at once. Think about how much you eat in one sitting. Then your stomach holds several hours worth of food for you. So with their groceries, they could have just taken one bag at a time up to their apartment, then back to the parking garage and made several trips. Or they could just load all of the groceries up at once and go. That's what your stomach does. Instead of constantly having to eat, taking a bite every few minutes all throughout the day, you just load your stomach up and then you're good to go for several hours. If you think about animals have stomachs and how this works. Animals are predators and prey. So if you think about a predator wants to be able to hurry up and load its stomach because it has to eat quickly before its food rots. Or before scavengers steal it, or another predator. If you think about prey, in order for prey to eat, they have to go out in the open where it is dangerous, where they could become lunch for a predator. So they need to hurry up and load up their stomach and then go back into hiding. So the predator, after he's hurried up and filled his stomach, can then have plenty of hours to leisurely digest that food. And the prey, after he's hurried up and filled his stomach, can then have several hours where he's back in a safe hiding place to digest that food. So that's the main thing your stomach does for you. It gives you a storage tank, so you're not constantly eating. You can fill up your stomach and then you're good for several hours. Also, your stomach churns food. So it mixes it with gastric acid. You have gastric juice here in your stomach. And the bolus mixes with the gastric juice. And your stomach churns to mix them together. So churning is muscle contractions. to mix the bolus with the gastric juice. And this produces a liquid called chyme. So once that bolus is dissolved in the gastric juice, then you have chyme. When you vomit, that's chyme that you see coming up. Another function of the stomach is it has acid. The pH of gastric juice is about 2. And this is because it has hydrochloric acid in your stomach. This acid does 2 things. It kills germs. So your food is not as clean as you would like to think it is. Every time you eat food, you're also eating germs. And it denatures proteins. This makes the proteins easier to digest. Okay. A fourth thing that is happening in the stomach is enzymes working on digesting food. There's 2 enzymes at work in the stomach. Pepsin is an enzyme made in the stomach. And it will digest protein. It breaks proteins up into smaller pieces. Then you have that lingual lipase. You might remember this, it was in the saliva. So it's mixed in with the bolus while it's in the mouth. And then it is activated by the stomach acid. So then it starts working on digesting lipids when it's in the stomach. And both of these enzymes, pepsin and lingual lipase, are activated by the stomach acid. So if you recall from chapter 2, enzymes are a protein. pH is very important to the function of proteins. They'll only work if they have the correct pH. And these 2 enzymes are meant to work at that low pH of the stomach. Okay, when it comes to absorption, the stomach doesn't do much. Your small intestine does the majority of absorption, but your stomach will absorb alcohol and aspirin. This is why you get drunk so fast on an empty stomach, because if there's no food in there to absorb the alcohol, as soon as you swallow that alcohol, it goes right through the stomach into the blood. And the 6th thing is that the stomach makes intrinsic factor. Okay, think back to chapter 7 when you learned about bones and calcium. Remember we talked about calcitriol and calcium? What was the relationship there? You have the same relationship between intrinsic factor and vitamin B. You have to have intrinsic factor in order to absorb vitamin B from your diet. So an interesting thing here, you can have your stomach removed. This happens sometimes when people get stomach cancer. You can live without a stomach on one condition. If you have your stomach removed, you have to get injections of vitamin B. Because without your stomach, you would have no intrinsic factor, and then your intestine would not be able to absorb any vitamin B that you eat. And the other thing, if you have your stomach removed, you lose that storage capability. So people who don't have a stomach have to eat all the time. And they can't eat very much at a time. It's just basically snacking all day long. Let's look now at a gastric pit. The gastric pit is a microscopic, these are microscopic pits all along the stomach. And they have cells that produce things for the stomach. So we'll look at the different types of cells here and what they make. We'll start off over here. The orange ones and this pink one are mucus cells. So their name pretty much tells you what they do. They make mucus. So you can see here this kind of coating. So this is a slimy coating that protects the stomach. The stomach is full of acid and enzymes, and you have to protect yourself from that. So that's what this mucus does. These purple ones here are chief cells. The chief cell makes pepsinogen. This is an inactive form of the pepsin enzyme. So if we follow this arrow up, here is where pepsinogen would go. Once it gets out in the stomach and it mixes with the acid, it becomes activated to pepsin. And then this blue thing here is a protein. And here you can see digested protein. So then the stomach acid activates it. And then it will start to digest protein. Next we have G cells. These right here on the bottom are G cells. G cells secrete gastrin into the blood. So you can see here, their arrow is going to the blood and you have these little blue triangles. That is gastrin. They do this when food enters your stomach. So this is what happens when you eat. And gastrin is a hormone that goes into your blood and it travels through the body, but then it comes back and stimulates the stomach. So when you eat and you fill your stomach, then your stomach has a lot of work to do. And so when the stomach gets food put into it, these G cells detect that and they secrete gastrin into the blood that flows through your whole body. The gastrin goes everywhere, and as it comes back to the stomach, it then stimulates the stomach to work harder. And then this one, our last one, is a parietal cell. This cell secretes three things. It secretes hydrogen ions and chloride ions. It secretes them separately. Then once they are out in the stomach, they combine to make hydrochloric acid. The reason you secrete them separately is if you made the hydrochloric acid inside the cell, it would kill the cell. You can't fill cells up with acid. So the parietal cell has to secrete them separately, let them combine once they are safely outside the cell. The other thing that the parietal cell secretes is intrinsic factor. And remember, this is what we mentioned that you need in order to absorb vitamin B. All right, so there's an overview of the stomach, its functions, and its secretions.